Okay, I hope everybody's back. Sorry for the short break, but I think it's very important that we have the interaction that we just had in the question and answer session. Up next is Cybicom Atlas Defence, and Dave will be leading the presentation. Dave, over to you.
Yeah, many thanks. Many thanks to everyone who's logged in and that's joined the industry day today in the presentations. So my name is Dave Vergoon. I'm the Managing Director at Cybicom Atlas Defence. Let me go through to the next slide. So the structure of my presentation today, we're just going to have a very brief introduction into who Cybicom Atlas Defence is. We'll have a look at some of our current projects. We'll talk about ballast water treatment in terms of an overview. Then we'll look at the project that we did with the support of dtic. We'll look at the objectives, what were the outcomes, and what are we doing moving forward. I think from my point of view, I quite like presentations to be a little bit more informal. If you've got any questions, please unmute yourself and fire the question at me as we go along. It'll just make life a lot easier because then we can also work out in what context the question is being raised. I should finish probably well within the time frame that we've got. We don't have too many slides to go through. So yeah, let's crack on. So Cybicom Atlas Defence, we're a company that was created in around about 2003. We were the result of the technology transfer that was done as part of the original obligations arising from the strategic defence package. And I'd like to think that we're a very good example of a successful offset program. Not only have we been able to maintain the capability, but we've also grown over the years. I think we started off with around about 3 people in 2003. And these days, we're a lot bigger than that. We're sitting at over 25 people now. But more importantly, we're not just solely reliant on the original technology transfer for income generation. We've been able to take the technology and adapt it and evolve. We are the local partners for ThyssenKrupp Marine Systems. That's the shipyard that built the 4 frigates and 3 submarines for the South African Navy. We're also the local partner for Atlas Electronic, which supplied the combat system and the torpedoes that are used by the South African Navy, and also for AISI Marine Systems, which is supplying some of the radars and the mission management system for the new Biro vessels. We have done quite a lot of projects, but just some of the ones that are more applicable to this particular channel. We've developed quite a lot of simulators and stimulators in both the marine and airborne domains. We've developed things like submarine escape hatch signaling systems, which have already been exported to Daewoo shipyards. Many of you might know that the Indonesians lost a 209 submarine recently. They had 5 209 submarines, of which 3 had our signaling system, escape hatch signaling system. And the submarine that was lost, unfortunately, was one of the ones that didn't have our system on board. But yeah, we undertake a lot of combat suite integration. Our engineers are also used by, for example, Atlas Electronic overseas as part of their field service activities. So our guys work on submarines for other countries. We've provided depth B, C, and D maintenance and support for the South African Navy submarines for the weapon system, and the combat system or sonar system. And we've also built a 4th land-based submarine command team trainer, which you can see in the pictures on the right-hand side. There you'll see a periscope simulator that we built, and the AISI consoles, which is the combat system on board the South African submarines. Some of the current projects that we're working on, we've got 2 periscope simulators that we have developed in conjunction with the OEM, Hensoldt Optronics. In fact, the picture that you see on the top right-hand side there is one that was installed literally within the last few weeks in Cartagena in Colombia. We have another one being installed early next year in Peru as well. We provide logistics and support on behalf of foreign OEMs, as I mentioned, from a TKMS perspective. We've done a lot of work in terms of supplying airborne optical sensor interface test hardware, and then we've progressed that into actually developing the training simulators for optical sensors. We are currently integrating a drone with a locally developed and produced hopper for the dispersal of moths to assist with the citrus agricultural sector. We upgrading a helicopter-borne stabilized camera gimbal used for surveying as well in the agricultural sector. And we're launching our new naval command and control system, which is called Trident Tactical. That's quite a whole large topic all on its own, but yeah. And of course, the ballast water treatment system, which is what we're going to talk about today. So ballast water treatment, what is it and why is it important? Well, ballast water reduces the stress on ships' hulls, provides stability, improves propulsion, maneuverability. As you can imagine, as ships move from port to port, their center of gravity and weight changes because the cargo is often moved, and they use ballast water to compensate for this. The problem is that the taking in of ballast water poses a serious ecological concern. If you can imagine a ship taking on water in South America and then discharging the water here in South Africa, you know, all of the bacteria, microbes, invertebrate, eggs, this kind of thing that is contained in that ballast water is obviously not good for the environment that it's being discharged into. So after about 14 years of complex negotiation between IMO member states, they adopted a consensus, and the Ballast Water Management Convention came into effect in around about September 2017. It's a layered approach that gives ship owners some time to implement changes. There are different ways that ships can handle the ballast water treatment. But I think as time moves forward, it'll become more and more rigid in terms of the implementation of the convention. Sorry, wrong way. So in terms of ballast water treatment, there's a lot of methods that are available already. A lot of times the different technologies are used in conjunction with another technology. So you have chemical treatment, filtration, ultraviolet, reverse osmosis, and then IMADO, which is the electromolecular activated direct oxidation. Each of these different technologies tends to have pros and cons. As you can imagine, chemical treatment, you know, it's not ideal to be using a whole lot of additional chemicals. Filtration requires the filters to be replaced fairly regularly. Ultraviolet, you get ghosting, and you have to have the water stagnant for a while. RO, you have quite a considerable power requirement. So we focused on IMADO, which is a technology that has been developed locally here in South Africa. The technology has been applied locally for wastewater treatment and also for water treatment for pharmaceutical production. So we had a look at this technology and we decided we could try and adapt it and have a look at it to kill any of the organic load in wastewater. So just from the outset, it's not that we are cleaning the water to make it potable. We're not taking out any of the toxins or anything like this, but our aim is to kill any of the organic load in it. So from an Amado point of view, it's a continuous low current, low voltage current that's supplied into the water, which by itself then triggers a set of chemical reactions. So there's a molecular breakdown, some oxidation, it creates a free hydroxyl. So there's a residual chlorine or hydrochloride that's left in the water. And the main advantages of using this technology versus any of the other technologies is the fact that there's a significantly lower power consumption. Also, the potential footprint on board ships would be considerably smaller. So if we look at the convention in terms of ballast water treatment, a lot of the ship owners will look at this implementation as being a bit of a grudge buy. So they want to do things in the most cost-effective way possible. And anytime you're trying to do a retrofit of any technology to a ship, you're always going to have power consumption, but also the physical integration of any new technology on board a ship is problematic. And so the guys are looking for the most simple and effective solution as possible. And this is where we feel that Amado does have a role to play and being able to do the job, but to do so in a way that is practical and, let's say, slightly more cost effective than any of the current methodologies that are used. So from the project inception, based on several discussions with both water treatment experts and various experts in the shipbuilding domain, there was a considerable amount of research done, and we identified this opportunity in the area of ballast water. But in order to proceed, we needed to make an investment to build a concept demonstrator. And in doing this, the funding was provided by the dtic to assist us, administered by AISI. And this funding enabled us to physically build a system and to conduct testing and evaluation. The test data is the most critical thing for us, and being able to move the system around and do testing in various locations was also quite vital. I'll elaborate a little bit more on the test results and some of the hiccups that we faced during the testing. So our objectives for the project. Well, as I stated, to build a test unit for the marine environment. This involved us selecting maybe different materials, housing the electronics in a slightly different way to protect them from the harsh environments. We needed to build a mobile trailer, which would allow us to move the system into different locations. We had to do multiple tests in both saltwater and freshwater environments. We needed to install additional generators and pumps so that we could operate in a standalone function. And the control systems were modified in order to work in the marine environment. And of course, there was lots of hose attachments and coupling that we had to take into consideration. The testing and evaluation system, we targeted a flow-through rate of around 4 kiloliters an hour. This is relatively low compared to what would be required for an onboard installation. But the reason is that it also kept the costs down in terms of the filters, the generators, and the pumps, and all the associated equipment that we had to put in. But it was definitely more than sufficient for us to conduct the testing that we had to do.
Dave?
Yes, sir.
I have a question from Nelson.
Sure.
It's in the chat, so I'll just read it for you.
Okay.
Dave, do you experience corrosion or damage from the environment created by the ballast water or the treatment thereof, and how is this mitigated?
So not in the reactors themselves, but certainly on things like frames and mounting points. There we've tried to use wherever possible stainless steel. So as you can see in the picture here, all of the piping is all plastic. So yeah, it is a major concern. Obviously, the cabinets need to be watertight to when we house in the electronics. Bear in mind that this system or the electronics, when it's installed on board a ship, will be in the engineering space. So it's not going to be, let's say, exposed to salt water on a continual basis. So I don't know if that's answered the question.
I believe so. We'll see if there's a follow-up question, but I think it should have been covered. Oh, we've got a shot. No, perfect. Thanks.
Okay, cool. So yeah, from a project point of view, I think we were quite happy that we achieved all of the objectives that we initially set out in terms of the project. The physical aspects of the project went pretty well. Where we did run into some problems was during the testing and evaluation phase. And I'll elaborate on that a little bit more in the next slide, I think. But in general, we were very happy. The system proved to be very effective in both freshwater and in saltwater environments for E. coli, phytoplankton, zooplankton. And it was quite interesting because for the plankton tests, as an example, we had to go and cultivate the plankton and grow it in order for us to be able to do the tests. So yeah, the outcomes of the whole ballast water treatment system. So the system was stable in a low flow mode. When I say it was inconsistent in a high flow mode, out of 7 batches of testing, which are broken up into a round of both freshwater and saltwater testing with 5 different samples being taken. So it's quite a lot of samples being done. We had one result that didn't make sense for us in a high flow mode. And this is where we thought the whole process would be relatively easy. We would build the thing, go and do some testing, get some results, and that would be it. But the process of doing the testing itself ended up being quite a challenge because the results that we got from the labs sometimes were contradictory to each other. Sometimes they were orders of magnitude different from each other. And so we had a lot of challenges trying to get the labs and trying to understand how the labs were processing the samples. And when I say the processing of the samples, so we would take 5 control samples. One sample was taken pre-treatment and kept at room temperature. A second control sample was kept in a chilled state. And then we would take a sample after filtration, but before the reactors. And then we would take 2 samples after the reactors, one in a high flow pass and then one in a low flow pass. So as I say, we definitely had some challenges, and what became quite clear is that the laboratories here are not really suited to dealing with water samples and analyzing of water samples that have got a very high bacterial load. And this is quite interesting because it's going to become quite a challenge for the South African government when they start to police the ballast water convention in terms of foreign ships coming in, because there'll have to be some form of testing protocol put in place, and yeah, it opened up quite a big rabbit hole that we had to go down. But at the end of the day, that was probably our single biggest overrun on the project was definitely on testing. As I say, instead of doing one round of testing, we ended up doing 7 batches of testing, which, as you can imagine, each sample you're going to pay the lab. There's also the time that's involved in doing it as well. The mobile trailer ended up being a lot larger than expected, but we did also identify some possible spin-off applications for the water treatment. And one of the processes that we've identified is to do potable water treatment in remote areas. That contradicts something I said a little bit earlier, but that's because if the system is combined with another system called a clarifier, the clarifier will then take out the sediment in the water, which would make potable water at a very, very low cost for rural areas. So it's able to do that if it's working in conjunction with another system. So the project has already been presented to DTIC. The project has been completed and it's been approved. Just some of the numeric outcomes of it. So the number of SMMEs that were supported was 5. Academic institutes and science councils. We involved 2 different academic institutes. As I say, we were also involving some labs that had to cultivate the plankton for us as well. Jobs that were directly retained because of this project were 3. Skills development was 1. We also took the opportunity to involve a student that was in 3rd year university as part of the internship program. So he got involved in the testing phase. We had a lot of support from the academic institutes in terms of how to do the testing, how to write up the test protocols as well. And yeah, the project was co-funded by Cybicom Atlas Defence. We knew beforehand that there would be a significant co-funding element from our side. Yeah, I mean, all of the overruns in terms of the additional costs for the testing phase, as well as the time the time overrun that we had were yeah, not really expected, but also not really surprising. I must also give a very big thanks to the guys at AISI. They were very understanding. Every time there was a delay with the testing, we would discuss it, we would explain why, and I think the interaction was very good. And I think the fact that we didn't want to have a mixed match of results, that we wanted to have as more solid a data set as possible, I think was the right call.
Thanks, Dave. Before we get to the next one, there's additional questions. I can read them for you. I know it's the way forward, but I think these ones you said you wanted to address them as they come through.
Yeah, sure.
Okay, so the first one was from Sibusiso, where he says, were these the only parameters you tested for?
Yes, there was, in terms of we looked at the IMO specification in terms of what it is that we had to kill. The one thing that we didn't test for, I think, was cholera. And on advice from some of the professors, they said that we are not equipped as a biolaboratory in dealing with cholera. And it would be too much of a risk to test for cholera. So that was the one test that was omitted. But the other 4 are all in line with what are the requirements stemming from the IMO certification process.
Thanks, Dave. I think that addresses Kevin Watson's question. Was the testing done against IMO standard or purely on demonstrated performance?
So yes, there is a specification from an IMO point of view, which spells out the effectiveness of your testing, and that's what we were working against. So yeah, we had a target that we had to meet, that's why the testing was problematic. So you know, we would have to take the rig out to different locations. And this is also where maybe a controlled environment would probably have been better in hindsight, because we would go to the same location, you know, 2-3 days in a row. And on one day, the lab would say that the water is of potable drinking water standard, and the next day they would say that it's several thousand times over the limit in terms of E. coli. So the results that we got from the lab were a little bit confusing, but what we were able to prove, because of the multiple samples that we did, so we had the two control samples in the beginning. As I say, one is kept at room temperature, one is chilled, and then the three other samples, so one post filtration and the two after filtration and after the reactor process, we are able to then take those. We took it directly to the lab straight away, so the tests were done very, very quickly, and then you're able to see the effectiveness of the system in terms of the counts. So yeah, we were working to a standard.
Thanks, Dave. I think that's sufficient. Also, Kevin just said well done, and I have to agree with him. The next question, yes, some good news as well. Next question, are submitting test reports to SAMHSA or Environmental Department or both? I don't think we did submit any tests, but you can just answer that.
No, we didn't. So we did draw up a very comprehensive test results document, which we are more than happy to make available to anybody who likes sifting through tables and tables and tables and tables of data. Yeah, so it kind of moves on to where we're going to next, I think, in terms of what is the way forward. As I say, the problem we faced in doing, let's say, in-field testing is the fact that the contamination in the water varied from one day to another. We also got inconsistent results from different labs. So we would often take multiple samples and send to different labs to try and collate the results. The point of the project, though, for us was to prove that the system is effective. In order for us to move on to the next phase, we would have to go and get IMO certification through an accredited authority, Germanische Lloyd, DNV. That process is extremely expensive. So we would have to get a significant amount of investment to move through to that phase. And it also takes quite a long time as well. And I think anyone who is going to have that discussion with us in terms of going through the process of IMO certification, I think we probably need to do more testing. I mean, we do have quite a lot of test data and test results, but I think we probably need to do more testing in order to satisfy a potential investor moving forward. I do think there's a very strong business case for this, though, moving forward, because I mean, if you go to the IMO website, I think there's somewhere between 38 or 40, in the low 40s, the number of systems that are certified for use in ballast water. And as I say, the advantage of using this technology is the fact that it's got a very low impact on the vessel, which I think would be of great interest for current ship owners who have to consider a retrofit to now be in line with the new IMO regulations. Another complete spin-off to what we were able to do is to look into using the same technology now. As I said, there's two different branches that we're looking at, which are slightly outside of the realm of ballast water treatment. And the one being process water. So there's a lot of factories and plants that require water, and the water that's provided is not 100% usable. This system is able to clean up the water and assist in process water application. And then the other one that is probably more exciting from our point of view is to apply the technology in conjunction with a system called a clarifier, which would be able to be used for the water treatment to potable standard in rural areas. Now, the nice thing about it, again, being small, it's mobile, the power consumption is so low that it can be powered by solar. So we certainly looking into those avenues as well. And that's it from our side. I encourage as many questions as possible.
Thanks, Dave. I think there's one left on the chat. Can the system also be used to test quality of the water?
Unfortunately not. So that's where the labs come in. So all of the testing and evaluation has to be done through laboratories. And this is it's a spillover to what I was saying in terms of how is the government going to regulate foreign ships coming into South African waters in terms of their compliance to this ballast water regulation, because it's a potential revenue stream, if fines are being imposed on ships that are not compliant. But in order to issue fines, you have to have the correct testing protocol in place, which is something that we need to investigate and discuss further within South Africa.
Thanks, Dave. There's no more questions in the chat. So if anybody's got a question, you can either raise your hands or just unmute and go ahead.
Also, guys, if anybody would like a copy of the presentation or would like to contact me for further information afterwards, I'm 100% happy.
Thanks for that, Dave. There was a question for somebody that asked for your contact information, which is currently on the screen.
No problem.
Okay, Gerald, go ahead.
Hi, Dave. Thank you very much for your presentation, and congratulations on what's it, the project concept that's been realized. It's good to see that these programs are working. Dave, my question is, how adaptable is your current system, to, let's call it the plug-in and play, with regards to the IMO's regulations on foul cleaning and all these things, and looking at your system, cleaning or the treatment of ballast water, don't you think, or my question is, how does a system like the cleaning cart fits into your ballast water cleaning system? Thank you.
Sorry, Gerald, I'm not 100% sure I fully understand the question. You're asking, how does a cleaning cart fit in?
No. The basis of the question is, your system is all about, water treatment, and especially the ballast water from ships or wherever.
Yeah.
There's an IMO regulation that talks about, the foul cleaning of all ships that enters our South African ports. So now, for the anti-fouling cleaning cart, you also need a system which is basically like taking out all the foul or the foreign foul, and making sure that the water that will return to the sea is, cleaned or treated or whatever. So the question is it possible for this system of yours to plug into a cleaning cart where it basically, purifies, is probably a better word, that water, or is it specifically just for ballast water?
Okay, understood. So the answer is no, it's not specific to ballast water treatment. It's that we identified a looming requirement for ballast water treatment systems moving forward. For the fouling, the cleaning of decks and anti-fouling and this kind of stuff, the system that we've got can plug into that, but it's only half of your solution. So what we are able to do is kill any of the organic load that's in there. But I think from your perspective, the second part of it is something that is probably more important, and that is the elimination of toxins and heavy metals and that kind of stuff from the water. Now that is done using a system that is very closely linked to the technology that is being developed for the ballast water treatment, and that's a system called a clarifier. So to answer your question, yes, we can do it, but it would require two different systems to work together. And yes, they can be done as an add-on.
Thanks, Dave. Thanks, Gerald. So there's no additional questions. I'm going to thank Dave. Thank you for your time. We have a slot at the end of this whole session again for additional questions. Otherwise, you're more than welcome to post additional questions for Dave in the chat, and then Dave can just address them.